Thank you. Nice try. Surprised you got a hand on that one. All right. Example 5. A student messing around during class slid a 2.5 kilogram penny off the top of their 1 meter tall table with a velocity of 3 meters per second. How far from the base of the table does the penny hit the floor? Okay.
Just the right distance.
Now, before we get going on our X and Y list, which we should have already started on,
I did.
okay, let's think about this 3 meters per second. If we're sliding a penny off the table,
Yes.
is that velocity vertical, horizontal, or both?
Vertical.
Rex?
Are we ignoring
Horizontal.
Yeah.
Horizontal. Are they the same
The tabletop is horizontal, right? That's why I picked the table, not a desk. The tabletop is horizontal, right? So this velocity is horizontal. The 3 meters per second is right there. Horizontal. Now we want to see where that penny lands. Right? What's that, Lock?
We ignoring air resistance?
Yes. So we want to know this distance right there, right?
Sure we do.
That's what we want to know.
I don't think we want to know. You.
I do. Okay. More importantly, we could call this distance 0 and this d right here by itself is what we want to find. Okay. Does that make sense? Okay. So,
What is 0 when you start sliding?
but in the x direction, this spot is the same as this spot, right? Okay. Okay. So in the x direction, what do we know?
Velocity is 3 meters per second.
Okay. Is that initial, final, or what? It's all of the above, right? Because what's acceleration in the x direction?
I was right.
0.
0. Right? What else do we know in the x direction? Come sit
It's
next to her.
traveling that
We
way.
know the penny is going that way.
Yeah,
just sit there.
Okay.
I'm just being
What else do we know? Where do we start?
0.
0. So D naught is 0. Where do we end? Don't know. That's what we want to find, right?
D final.
So D, right here, that's what we want to know. Do we have enough between velocity, acceleration, and initial distance to find where we land?
No.
No.
We should do some wide stuff.
Okay. We need something else, though. What's the other thing we need?
Wide.
We need our time. Because, Rex, when you said let's do some Y stuff, Y doesn't help me except if I'm using Y to find... No? Except if I'm using what? What's the only quantity that's a scalar? Time. The only quantity in what we're talking about right now that's a scalar is time. Right? The only quantity, Eric, that goes between the x and the y direction is time. So if we're finding time for the x, or if we need to find time for the x, we can get that from the y. Yep. The only thing the y can help us with, though, is finding time. Velocities, accelerations, displacements in the y direction don't affect the x direction. The only quantity that affects the x direction is time. So let's make a y list.
I have a question.
Yes?
How come you direct one to the right?
I don't know. Okay. That's the way I drew it.
I just wonder. Could you do it?
You could. Doesn't matter. Don't give us directions.
That looks more like a brick.
Y direction. It's a cross section of the penny. If I drew the penny smaller, you'll be able to see it, Caleb. Here you go. Here's your penny. A little smaller now. Not a brick. Alright. Y direction. What do we know? What's the acceleration? Positive or negative? Negative. That means we're calling up positive. Yep, there we go. Anything else?
Make that up.
Make it a lot of non-reference frame. Okay. Anything else? We do know some other stuff. What's our initial position?
1 meter.
1 meter. Good.
There we go. Good job. Good job.
nice job, Kyle.
What's our final position?
0.
0, because we end up on the ground.
Look at that.
What else do we know?
Some other stuff.
Some other stuff.
Another number.
Great, we do know another number. Thank you. Horizontal velocity of 3 meters per second. That's our initial, right? What does that tell us about the y direction? Jose. If we have initial velocity, it's horizontal. What's our initial y? What's the y component of this triangle right here? You're probably saying it's not a triangle. It's just a straight line.
Yeah, sure.
So what's the y component?
0.
0. So v naught in the y direction is 0. Anything else we know in the y direction? Anything else we know in the y direction?
So you're making this hard, French. This is easy. You let us do it. But then when you do it,
You ask this?
Rex, I asked you to make a list and you didn't do it.
you didn't know.
This problem is very difficult if you don't make a list. Because then you start confusing your two directions.
Easy when you're not counting us.
Alright. Well, that's usually you just sit there then. What else we know? What are you trying to find?
Just
Time, right?
Yeah.
We need time because that's going to tell me time in this direction, right? If I know time in that direction, then I can find my distance in the next direction, right? So, what equation can I use for the y direction? I think we got everything from the screen that we need. So, what equation can I use for the y direction? What equation has acceleration, position, distance, velocity? Which one? 3. Caleb, which one? Okay, 3. Just like what Rex said, right? So, if I want to find time in the y direction, we use equation 3. Equation 3 looks like this. D equals 1/2 at squared plus v naught t plus b naught. Right?
what's that?
That is the projector.
So we only use
Cooling
one
down.
X or one Y to put
Yep, we only use x or y. Okay.
Processing on.
Now, in the x, we have 2 unknowns, d and t, right? In the y, we have 1 unknown. So which one should we start with? The y. Because if I find that t in the y direction, that's the only variable that can go in the x. So once I know that, I can put it here. Now these are some vectors. Right? T is not a vector. So now we can take this information and plug it in, right? D is 0. 1/2 times negative 9.8 t squared plus 0 t plus 1. Right? So now let's solve this, Rex. You want to do it?
Nah.
You said I make it more difficult when I do it, so how about you do it?
I'll do it.
You do it in mine, what do I do first?
Oh. Plug it in your cup.
You can't plug it in a calculator, we have variables.
Oh. You. And take off.
Yeah. Simplify, right?
Simplify.
Simplify what's going on. So to simplify, we multiply these first, right?
Yes.
Yeah, what's that? You get 4.9 t squared, right? Do I need to keep my 0 t? No.
No.
Do I need to keep my 1?
Yes.
Now what do I do? It's algebra time, right?
Yeah.
What do we do now?
Take away 1.
Okay, subtract 1 from each side. Sure this is going to work out? We can't square root negatives. You sure it's going to work? Yeah, it'll work.
Yeah.
Because what do I have to do next?
Divide.
By divide by negative 4.9. So negative 1 divided by negative 4.9, the negative signs will cancel, giving us a positive
2.204.
perfect. Right? So it takes 0.2 seconds? No.
Now you have to square root.
Good, Michael, wake up. We gotta square root that. So the square root of 0.204, what does that equal? 0.451. So how long does it take the penny to hit the ground?
0.45
0.451 or 0.45 seconds. Does that make sense? Rex, does that go along with our little experiments we did when starting this problem?
Yeah,
I
sure.
think it took less than a second.
Sure.
Okay. All right. So this is 0.451 seconds. Now this quantity, 0.451, this is the only quantity that goes from the y direction into the x. Everything else I leave over here, but I can bring the t over because it is a scalar, right? It has no direction.
Sure.
Does that make sense?
Sure.
Rex, I really appreciate your affirmations. So we know that time now is 0.451 seconds. So we know velocity, acceleration, 0, d naught, d, and t. Which of our equations has distance and velocity but does not have acceleration? 5. 5 has distance, velocities, and no accelerations. It is. You were right. Nice job. Okay. Now, we could also use equation 3 because when I plug in 0 acceleration here, that goes away. And we basically get what we have for equation 5. So either one will work. So when in doubt, equation 3 might not be a bad place to start. So let's plug in what we know. We don't know distance final, so we're trying to find. We know velocity is 3. We know time is 0.451. We know initial position is 0. 3 times 0.451 is
1 point. Oh yeah, 354.
so distance is 1.35 meters. So the penny will fall, will hit the ground 1.35 meters away from the base of the table. Does that make sense? Yeah. Okay. Second part of the question. If another student dropped a marble from the edge of the table at the same instant as the penny flies off the table, which will hit the ground first? So another student is holding a marble, not in the way of the penny, but very close.
Sure. How about you just draw your little marble contraption?
Could do that. The penny gets hit off, the marble drops, right? Which one hits the ground first?
Same time.
Same time. Why same time, Fawn?
Because I'm smart.
Because Rex is smart. Why same time, Fawn? Okay, good. They have the same vertical acceleration, right? What about initial vertical velocity? Is that the same? Initial vertical velocity. Both 0, right? Same height, right? That's exactly right. It's the same time because they have the same initial vertical velocity, which is 0, same drop distance, same acceleration. Right? Are there any questions?